Hello, good evening, everyone. Welcome to this stream number 28 of this Amiga assembly programming series in 68,000. As always, I start by thanking Fabio Ciucci for giving me the permission to stream his book, and thanks to him is that these streams are able to happen. So much obligated to Fabio, and special thanks to him. So let's continue what I left last week. So last week I said that today I will start talking about DMA Con and DMA Con R. We were talking about DMAs last week and what can be switched on and off and what happens and when they are all on and what is the raise that there is to the memory, etc. However, we didn't talk about one particular DMA, which is the DMA Control Registers. There are two of them. One is read, one is write. DMA DFF096 is write, DFF02 is read. However, before I even start explaining the registers, I'd like to get to your attention, okay? First of all, actually, before I even jump to there, to where I was going to go, I need to, let's go into the browser. And let me, where is it? Here. So, come on. Yeah. Sorry, I need to bring the other browser on because I have two browsers on and this one. So, I have shared a page with you guys with all the links related to the book. Here, I mean, to program, to do assembly programming on the Amiga. So it's not just the book, there are other stuff that you will need. And here I created this page with all links related to the book and Amiga manuals, reference manual, and other stuff. 68,000 pages and some tutorials, emulation, and all that stuff that you will need. Okay, so you will find this from time to time appearing on your in the chat, but also the moderator, when they are online, they will, because right now there is no moderator, they will show this page. They will share this link to this page. I'm going to share it, but those that are on Facebook, okay, will not be able to see it. And the reason why is, as I said, Facebook is a strange platform and the communication is one way. You type a message, I see it, but I cannot send you messages back. While if you're on stream, you see my messages. I'm noticing actually why it's not showing Sorry, I needed to switch like this. This is the page. Sorry, I didn't switch to the page. This is the page that I was talking about that I shared with you. Okay, and this is where the book is. We can download the sources related to the book, links related to Amiga and information that you might need, and also 68,000 stuff. Plus, you have other tools and things that you will need. This page is being updated as I go along with the book. So every time I encounter something that needs to be added to the book, I will just post it here. So this is the official page in a way with all the links related to the book. However, if you go on Discord, you will get this, I mean the link to this page, but also to the others. You'll get the links to all the rest. So yeah, I could not make it, I think, easier than to you guys than what I did. So um, let's continue to the book where we were. Okay, actually, let's go to the whiteboard, what I was going to explain, because that's when I stopped and showed you the link to the page. But this is what you need to see or understand. Please note that many people make a mistake, and I'm just going to switch temporarily to the browser, okay? Here. People do this mistake. That is, they come to the list of registers for the Amiga. They think that they know, by looking here, that they know what needs to be done, okay? But actually, writing a 1 in this bit doesn't mean you get audio enabled. Many do this mistake. It doesn't work like that, and I'm going to explain why and how it actually works. Please note that these registers, okay, these two registers, DMA Con and DMA Con R, okay, read and write, okay, the same. There are other registers that function like these registers that has got a master switch. Let's put it in sub-master switches. So you need to understand this system of registers. So let me go back to the whiteboard. Okay. So bit 15 is the master switch. Okay. First of all, we all live in a house and we all know what a distribution box is. The electricity distribution box, okay? The box where you have all the switches. If you, as you know, you have a master switch, okay? If it's off, everything is off. If it's on, it doesn't mean that the others go on, but you need to have it on for the others to come on. So that's the first thing that you need to know. Secondly, okay, there are switches which are independent. Once you turn the master switch on, these you can switch them on when you like, okay, or off when you like. However, there are others that also that are grouped under another master switch. For example, the switches in the kitchen, okay? Because of that, you need to have the master switch on and then have the appliances in the kitchen like fridge, cooker, oven, whatever, on. If this is off, nothing comes on. So, in a way, okay, these registers work similar to the system. Not exactly, but quite close. it's because I could not think of a better way of explaining it. This part that I'm saying is not in the book. I am doing this analogy of comparison and showing how the switches work. So let's return back to the book. Okay, so we control the DMAs through these two registers. As I said, the first register is DFF096, which is the write register. Okay, this controls what is switched on and what is switched off. DMA Con R, which is DFF02. Okay, so the registers are here. Okay, are mentioned here. I know that you do not understand Italian, but you have me. I'm explaining what's in that paragraph. Also, code is code. It doesn't change with whatever language we speak. Okay, assembly is assembly. We all can understand it. As long as we understand the principle, you can all understand it. Of course, if you've been following this course, if you just jumped, then you need to do a bit of revision and go back and see. But the theory remains the same. Okay, so as I said, the FF002 is a read-only register. Okay, we read to see what's set on and what is set and what is not set. Okay, so here are the registers. Okay, these are the registers. Okay, sorry, the bits which form the register. The registers are identical except for some bits because when you are reading, you don't need all of these. So as you see, bit 15 is the master switch, okay, that I was saying. You write, you enable this bit, you put a 1 if you want to change anything in the other bits. If this is at 0, okay, whatever you put 1 in here is switched. Now, I am not being exactly 100% correct, but for now, just bear with me, okay? Also, we have not covered blitter, but note that there are 3 bits related to blitter, which I will explain what they do, but we will do them. This is chapter 8, remember, and chapter 9 and chapter 10 are just blitter. So I will be covering these bits quite in depth when we do blitter. Another thing, yes, you can go and download the book. You will not understand the Italian, but there is the book theory. The book theory is only 400 pages long, but the exercises, I mean the amount of examples that there are, the book is 1872 pages. Okay, so 1872 pages, that means that there are a lot of examples that can teach you how to use the Amiga and how to program the Amiga. So you imagine the amount of code that there is. Hence, you just need to understand the theory, and once you understand the theory, you have the examples. You basically can go and write demos once you understand the theory. And this book was written with the intention for demo coders, basically, or games, and programming the Amiga directly. Okay. So here are the registers. Okay. Now, as I said last week, we have 9 DMAs. Okay. So 0 to 3 are the audio DMAs. Okay. Then we have the disk DMA, then the sprite DMA, the blitter DMA, the copper DMA, and then the bitplane DMA. And funny enough, we have a master switch again. To do anything with these, you need to have the master switch on. So there has to be a 1 there so that something else is turned on or off. Else nothing happens. But at the same time, you need to have this one also. So it's 1 and 1 to be able to do anything on these. Okay? You cannot have 1 here and 0 here. It will not work. Well, it will work. It will switch off, actually, what you are telling it to switch off. As I said, bit 10, bit 13, and bit 14 are related to blitter. 12 and 11 are not used. So let's start with bit 15. This is the most important bit, okay, of this register. If it's a 1, that means that you can go and start switching other things. If it's a 0, it means you're switching things off. Whatever is 1 means you're switching it off. So remember, it's not exactly like the distribution box that I mentioned, because if it's a 0, okay, it doesn't mean that you switched everything off, but whatever has got a 1 in it will be switched off. So let's say you put 1 in bit 3, okay, and you have a 1 in bit 9 because you need to have a 1 there, and then 0 in bit 15. That means bit 3 is off. Okay, you switch that channel off, that DMA channel off. If you set bit 15 1, of course you need the bit 9 as 1, and then bit 3 as 1, and the rest are 0. Okay, the others will not be affected, but bit 3 will be on again. Okay, that's how it works. And you're going to see some examples. Notice now there's a small, not mistake, I think it's done intentionally so as not to confuse you, because we are talking about bit 15, not about bit 9. But for now, notice, okay, that when bit 15 is on, okay, and we put 8, 7, and 6, and remember 8, 7, and 6, splitter, copper, bit plane, okay, when these are 1, these become active. Now, in theory, you should also need to have bit 9 1, okay, but he is taking it one step at a time. So look at this now. We have bit 15 0, okay, we are switching off bit number 8, okay, and bit number 5, which are 8 is bit plane and 5 is sprite. Okay, so we switched those two off. Here he says bits 10 214 are related to Blitter, and we will not be discussing these, although he will say what they do, but we will cover them in the next 2 chapters. So here is a brief overview of what the Blitter bits do. Okay, so bit 14. The purpose of this bit is to know if the Blitter is being used, if it's busy. Note, we can go and modify the Blitter when it is busy, but I can tell you one thing, garbage you'll get out of it, and not a blit, because it will get confused. You need to wait for the Blitter to finish to be able to give the Blitter the next instructions that you want, the next copy or whatever you want to do with it. So this is why we have this bit. We check for this bit to make sure that the Blitter is free. Here is the bit that indicates that when it's doing a blit, the result is at 0. Okay? We use this for when doing bobs, when using bobs or software sprites. Call them whatever you like. I mean, the modern way of calling bobs is software sprites, but actually I am old-fashioned, let's say old school, so I will still call them bobs. Okay? And in Amiga terms, it is bobs. So if there's a collision between bobs, normally this is the bit that we read. Okay, it helps us to know if there was a collision, let's say. Now, this one, bit 10. If you recall last time, I said that the copper has got the highest priority. The Blitter is normally off, and then the CPU has got priority. And when I'm talking about priorities, I'm talking about who gets access to chip mem first. Remember, the CPU is comfortable in fast mem, but in chip mem, it needs to fight for its time because the custom chips take priority. So, this bit says that when it's enabled, even though the Blitter comes second and it is second priority, it also takes the time of the CPU. You can enable this bit and it takes more time. So the CPU will have less time. This is why it's important and why 30 years ago, when you added another 512K of RAM, which some call it slow RAM, some call it fast mem, but it's still fast mem because it's not accessed by the custom chips. Okay, because of that they call it slow mem, because of the way it is designed, more than it's because it's slower, because it's not directly connected to the CPU. However, the CPU always gets access to fast mem. The custom chips do not use fast mem, but when it comes to chip mem, okay, the CPU has to fight for it because the custom chips takes priority. This is why the more chip mem you have, the better. But at the same time, you need fast mem because the CPU, that's where it's happy. So now we arrive to bit number 9. This is the master switch for all the rest from 0 to from bit 0 to bit 8. Whatever you do, you need to have this 1. If we have this bit set as 1, then whatever is 1 will become active. Okay, whatever is 0, okay, becomes disabled basically. To disable a channel, you still need to put this bit on. Okay, so it works. So bit 15, okay, you indicate with bit 15 whether they will be on or off. With bit 9, you enable it, you put a 1, and with it you say which channels, which DMAs are going to be affected. Okay, so if bit 15 is set, okay, the rest, those that are 1, will be affected. Is bit 15 is 0, okay, the rest, okay, I'm excluding bit 9 right now, the rest, those that are 1, will be disabled. Of course, you need to enable bit 9 to be able to affect any. And here, now let's say, okay, that we want to disable, sorry, not disable, that we want to have bit plane, copper, and blitter on. So the first thing we need to do, remember, we are, for those that's been following this course, know that chapter 8 started with us creating a startup file, a universal startup file that we will use, and it will take control of the Amiga the proper way. Okay, before we were taking control of the Amiga, but it was not really the right way. Okay, this file, this startup file, will will make sure that we are really taking control of the Amiga without, let's say, chances of having gurus, because before we could see a guru much more faster and much more quicker than with the startup file. Hence why we need a startup file. It's a unique file, it's a universal file, it's a common file that we always use, and then we add the code to it. Okay, that's the main scope of the startup file. So the first thing we do, okay, once we take control of the OS, we do not know, okay, what registers were enabled or disabled. So we switch everything off, okay, and this one, okay, is writing, look, bit 15 is off, 7FFF in DFF096. As you see, bit 15 is off, everything else is a 1. We are clearing everything off. Okay, we are setting everything to 0. Then we tell it, okay, we enable bit 15, we enable bit 9, and then 6, 7, and 8, which are blitter, copper, and bit plane, are enabled. Okay, and like that, we have enabled those 3. To switch everything off, we always write this value, binary value. Here is what I said or gave you a hint earlier, and it is in red for a reason. The way this register works, these two registers work, is the same as the interrupts work. And the interrupts, I mean, there's a chapter related to interrupts. I believe it's now chapter 11, either 11 or 12, I can't remember exactly. But interrupt enable and interrupt request, okay, work on the same principle. In all our listings, okay, so I'm just going to say what this paragraph says, but in short, okay. In all our listings so far, we have never used DMA Con and DMA Con R. We have ignored them, okay. We just assumed, okay, that the DMAs are there, are enabled for us. Well, in a way, this was by coincidence in a way, because the assembler need to have the screen on to be able to function, need to have a mouse pointer to have sprites, so the mouse pointer was enabled, okay, and need to have the copper to display the colors. So we had bitplane, copper, and sprite enabled for sure, okay. And the reason being is because the assembler itself needed them. However, imagine us running or trying to run something and we come from an unknown state. It doesn't mean that those were enabled. So our programs that we did before, okay, might not work always, depending what was enabled before we took over the OS. Hence, we were assuming too many things, okay. Now we are making sure, okay, that in our startup file, okay, we are enabling what we need. And that is this example up here. These examples up here are telling us, okay, we switch everything off and then we switch what we want on. Now, before, when we are, before we take control of the OS, okay, and switch off the OS and take control of the Amiga and we want the hardware for ourselves, okay, we need to save the status, of course, of the DMAs, okay? And we do that by reading DFF002, as indicated on the screen, as you can see on the screen. Now, when we read DMA Con R, okay, we are just reading it. It's not going to have bit 15 on or off, okay? Bit 15 is not used in this case, okay? It's only from bit 0 to bit actually 14, but we are interested right now because we are not covering the blitter from 0 to 8, okay, and 9 and bit 9 to enable. So when we are reading it and storing it and saving it, we need a way that when we are returning back to the OS, we set those bits, because when we read it, bit 15 is at 0. So here is what we do. First of all, we have sorry, as I said, writing 7FFF, okay, in 096, we are resetting the channels, okay, resetting all the MAs. We read the registers and we reset our DMA. Now, when we enable something, we said we enable bit 15, okay, and then of course bit 9. Now here is there's like a small bug in the book, okay. As you see, the 5 is under the percent. The 5 is on top of the percent. It should be on the 1, okay. So this 0 is with this 0, so this 9 is with this 1, okay. And here we have 8, 7 and 5 enabled, which are 8, 7 and 5. So bitplane, copper and sprite. Blitter is not enabled. Okay, it's red, so that means this is important what's written there. So we have saved the register, okay? We have saved what DMAs the OS had enabled when we took over. But when we write back, we cannot write the same value that we saved, okay? We need to add bit 15. Because bit 15 is 0, okay. So how we do this, okay, and here is a small trick or way of doing it. So we read it and we store it in the 0, okay. Then we set bit 15 with the for the value that we have in the 0, okay. Then we store it. So then we store, okay, what we have in the 0 into our memory, okay, into our place where we are going to store the old DMA, which the OS has. When returning back to the OS, okay, so here we do our routines, and then we are returning back to the OS, this part, okay. So, as always, we reset everything, and then we restore our old DMA into DFF496. Okay, and like that the OS will have everything back as it was. Okay, this is being done for us in the startup file, but we need to understand what is in the startup file. Okay, now here we are using the bit set, okay, and bit set can only set 1 bit. However, when we want to set multiple bits, OR is better, okay. If we want to enable all 4 audio channels, okay, then it's better to use OR than bit set. But in this case, because we are only setting 1 bit, it's still valid, okay. Remember, AND is used to switch bits off to make them 0, OR is used to make bits 1. That's one of the many uses that we can use OR and AND. So, in fact, he's showing us, okay, instead of bit set, we can use OR, okay? And notice, with OR, he set this bit to 1, okay? The rest are 0. The values that there were here, they will not change, but we have ensured that bit 15 becomes a 1 if we use OR. So, So now he explains what I just said about OR, okay, in this paragraph. He says it is better that we use OR for because OR permits us to enable more than one bit instead of bit set. Also, I think OR is faster than bit set, but if you want to check out, I mean, I didn't check it out to see which one is faster or not, but yeah. For interrupts, it's the same thing, okay? Remember, they work on the same principle. Basically, that you have a master switch and then you enable and disable things as needed. So this is how. So remember, although we are not covering disk or we are not covering interrupts, our startup file still needs to take care of the DMAs. So this is how we save all the DMAs, okay? All the registers related to the DMAs, okay? So we are saving the DMA, we are saving the interrupts. Sorry, I need to rephrase myself. It's not how we save all DMAs, it's how we save all registers that I just mentioned, which are related to disk, interrupts, and of course DMAs. So here we are saving the DMAs. Here we are saving the interrupt enable. Here we are saving anything related to the disk. Okay. This one doesn't let me to select, but anyone. This one, line number 4, and then on line number 5, the interrupt requests. So that is how we save all these registers when we are taking control from the OS. Now, when we save them, okay, we save them in such fashion. Now we have all DMA, define constant word, and a byte of 0 and the word of 0, but then we will store that value there, no? And we do that for all 4 of them. I was saying that we stored the 4 registers, okay, the 4 word registers in this fashion. However, when we want to set the bit, okay, the bit 15, remember all registers work in the same fashion. Bit 15 is the set or clear bit. So Fabio is going to show us a trick of how to write to these registers, to these memory locations. As I said, we have 4 word locations where we are storing for our startup file the values, okay? But we need bit 15 enabled for all of these. The DMA con, interrupt enable, disk acknowledge, and interrupt requests. So instead of writing a move.word, look what he does. He does move.long instead of word. He does move.long and repeats, okay, 8000 each time. Okay, so 8000, 8000 into the 0. Like that, he's going to write bit 15 in these 2, as you see, and he's going to OR it and do dit 0 alt DMA. So these 2, bit 15 is going to be enabled. And he does it for the next 2. So he saved some really some bytes here, and of course the code is faster. Okay, so that's the first thing that he does. Now here's another trick he's going to use. He really likes saving memory. He really likes saving cycles. When we are returning, when we are resetting the registers, okay, he does the same thing. He writes 7FF twice in a long word. So basically, he has disabled the interrupts, okay, of both registers of the interrupts in just one go. Okay, he has disabled sprites and he has disabled DMA. So in the startup file that we are creating, we have all this. Then when we are returning back to the OS, we need to return everything as it was, no? So he is resetting everything. Remember, we reset everything from what state we are to switch everything off and then on. So he is resetting everything for all. So here is the DMA, here is the interrupts, and here is the disk. Okay, then remember we have enabled bit 15 for all of these. Then we are returning everything as we saved when we got control of the OS from the OS. So everything else is being returned to the state that we were. And that's basically the startup file, okay? But there's a small caveat, which I will come to in a minute to it. So we have done the startup file. Now we have a complete startup file, okay? The although we have covered everything, all possibilities, so we have less gurus, let's say, when we take control of the OS from the OS and we want to program the Amiga hardware directly, we still have to think about certain things. However, before we jump there, here's another thing that Fabio does, okay? First of all, he's going to explain the difference between EQU and equal, okay, in 68,000 terms, because in 6502 I think it varies a bit, but in 68,000 it is the same, okay? Basically, EQ and equal mean the same, and you write them the same. As you can see here, we have an example. Okay, it does nothing. I mean, the code is not doing anything. It's just adding two values. But what's interesting is to see how Kane and Gatto are initialized. Okay, they are constants basically. And basically, these constants are 10 and 20, and we wrote Kane EQU 10. Okay, the same thing, we could remove the EQU and have equals. However, in 68,000, the equals requires a colon for the label. Okay, but the assemblers, most of them, at least till 1995, okay, let's put it this way, when this was released, you have an option in the assembler to enable the colon or not. You can either switch it off or on in the assembler, and by default I believe it is off, so you do not need to add it. However, I most of the time still add the colon, so I am just old style, too much old style. But you do not need to have a colon there. So as you can see here, he is showing Kane with equal, and there is no colon there. To help us better, yeah, yes, yeah, EQ is equal, yeah. So they are interchangeable, but as I said, the syntax between equal and EQU, okay, varies, but it's hidden to us. The equal requires a colon actually in front of the label, but you can ignore it. It's just he's just mentioning so that we know, just in case we forgot or we went and disable it in the assembler. So in our startup file, we are going to have this part. I will show it to you in a minute, okay? We're going to have these remarks except for line number 2, okay? Where we will specify every time we include the startup file what DMAs we want enabled. And the startup file takes this DMA set, okay, the value that we set in DMA set, and enables and disables what we need in our startup. I think it's a quite nice way of doing it, to be fair. Hence, further down in the file, we will have DMA set setting the, in this case, what we have there, blitter and copper, because bit 9 needs to be enabled for the Amiga. Okay, so we'll have bit plain and copper. Remember, it's not just bit 15 that we need on, we also need bit 9. So bit 15 is what, I'm repeating this, but it's quite easy to confuse it. Bit 15 is what indicates what we are turning on and off or clearing. But those that you want to clear, you need to put a 1 in front of them. And to do that to work, you need to switch on the master, which is bit 9. Okay, yes, bit 9. So that's how it is done. Hence, okay, we're going to see the startup file now, which is lesson 8a. So let's jump to the Amiga. Now, this startup file, okay, is the actual startup file. It's not too fast. So normally you do an include, you include the startup file and then there is your code. But right now, Fabio is showing us the code, and there's a bit more that we need to talk about it. So that's why it's not complete yet in theory. But notice one thing, okay? Our code starts here. So from now on, okay, where start is, okay, the rest is the startup file, okay. Eventually we are going to remove that and we will have only this part, okay, in our code, in our file. The rest is included as a file, but for now we're going to have it. Now I'm going to assemble it and I'm going to run it. Now, if you remember from last week, what we have enabled here is we have the copper enabled and we have the bit planes enabled. There is no mouse, okay, there are no sprites. So I'm going to start using that DMA set, the EQU, and switching on and off, and show you what happens, which we should know. This we spoke about it last week, and now I'm going to show you exactly what happens when you turn certain things on and off. Okay, so let's say we want to turn off bitplane. Let's turn off bitplane. Okay, we are going to turn bitplane off. As you see, the copper is still there, but we have lost our screen. So, what a nice thing. I wish Windows can do this. I really wish. Or Linux. Or Mac OS. None of them can do it. Let's now... Okay, I'm going to enable the bitplanes. I know, it will never happen. They were not designed for that. But I still can wish, no? So now let's disable the copper. And you should know what's going to happen if we disable the copper. Remember, the copper has got the highest priority. For those that were here last week, they should know what happens. As you see, there's nothing on the screen. Without the copper, the Amiga doesn't function. Okay, the copper is everything. The copper is what starts it to display something, to have some colors. Then the bit planes is what we see on the screen. So I just need to make it back as it was. Okay, that's basically it for now for the startup file. I will go through the book. Now remember, there are two books. Okay, the Fabio book is divided in two. Okay, the theory book and the exercises, not exercise, examples book. So the sources are in the exercises book or lessons book or source code, whatever. Remember, the book is 1872 pages. So, but yeah, let's go into it. So, as you see, I have highlighted that EQU that I was changing. Okay, so this is what we need to know about. Okay. By the way, this startup file, I forgot to say, actually is good for any CPU. Okay, it's, I mean, till 68030 or 68040, I believe, because that's when this was written. The heavy in it, okay, you're going to see it further down, is what we just spoke about. Before I will switch to the Amiga. Okay, it's the saving of the registers and how we set bit 15, etc. Okay, But our code starts, as I said, with the start label. So because labels needs a colon, I tend to write constants with a colon. So that's me. However, I mean, it doesn't need to be like that. So this is all our code, and it's not really doing anything. I mean, here is setting the bitplane pointers, setting the DMAs that we said that we want, making sure that we disable anything which is AGA, okay, and then wait for the mouse button. So that's our code. There's nothing that needs to be explained. We saw that many times now. Let me see if there's any node that I need. Aha, yes. There's a routine, which I actually highlighted in yellow. This one. This routine, we discussed it in the book, but I am highlighting it to remind you that this works with Kickstart 3.0. It doesn't work with the other Kickstarts. So there's a check to know which Kickstart we are running, and then it will reset the sprite resolution, basically, because, as you know, AGA has more things, more fleshy things. So we needed, I mean, I discussed this routine, but I just wanted to mention it, just to make sure um, that I'm covering it again, because it's good to repeat. There's another one which is, I'm not going to, but I'm going to show it to you here, which is this. Before, when disabling the AGA, we only had 3 instructions. We have a fourth one, which is this one, to disable the AGA. Okay, remember, so far we are only doing OCS and ECS. We are not doing anything which is AGA. Eventually we'll cover AGA, but not yet. And that's basically it. Here it says go and change the things off and on, which I already showed you. So that's basically it, and we can jump to the other book. Remember, we are in the book of the sources, and this is the theory book. So um, he is telling us, okay, now we separate the startup file from our code. Okay, so now we're going to see that we separate our code and from the startup file. Okay, our startup file for now is called startup1. Okay, it's because we can have multiple startups also, but for now we just have one startup. Notice that before the include of our startup file, we have specified this section. Okay, we need to do that, and we also specified that the code goes to fastmem if it's available. If not, it goes to chipmem. Notice also that once we have included our startup file, the startup file will jump, as I already said, to our start label. Okay, and this is one of the first things that we do. We set the DMAs that we want by the EQU that I showed you earlier, and then disable AGA. Okay. One thing that is it's not a rule, okay, but it's a standard. Okay, I mean, it's like an understandable standard. Usually A5 holds the base address of the custom chip register, which is DFF000. So here, okay, when we say 96, okay, it's DFF096. Same thing is for the others. Okay, look, A5 has got, and here I made a note and I highlighted it in red, that A5 contains DFF000. Okay, this is our base address, our custom chip registers base address. And here we come to what I was saying. We think that we have the perfect startup file. Actually, I cannot jump to here yet. So we I need to show you example 8b. Let me see where it. No, not yet. Sorry, not yet. I need to do this part. I am running. So we think that we have the perfect startup file, okay, but it is not true. I tell you why. Okay, remember, the Amiga can either boot directly from a floppy and execute our program, or the program can be executed from Workbench. Workbench is the OS, and in the OS we have two modes, either through an icon from Workbench or through the CLI. So we need a way of detecting from where we are running our program when we are doing this from Workbench. Hence, here are two routines, okay? This part detects if we are running the program from an icon in the desktop, okay? And this part detects if we are running from CLI. Now, it is out of scope, okay, and it is really out of scope to explain the system calls that we are doing here, okay? Even Fabio doesn't go, and I tell you why. You need to know how task priorities, etc., work into the OS, which is not really, you don't need to know, because we are switching them off anyway. So just accept this code that it disables, actually it not disables, it takes notes related to the tasks and messages, etc., that we are running from an icon, and that is it. If you decide to skip this code when running it from Workbench, okay, what will happen is not a disaster, but if you don't have enough memory, you'll have an issue. Why? Because the program never releases the memory. So if you took 1 megabyte of RAM, that 1 megabyte is never released and stays there. That is why you need to use this code. Now, this code, we don't need it in our startup file all the time, also because there's a small bug. Okay, if you add this code for code that you are not running from Workbench, okay, you will enter in an infinite loop. Okay, so we add this code only when we know that our program is going to run from Workbench, else we comment it out. So this code is a separate file which we mark or unmark as we like when we are producing the code, when we are compiling the code or assembling the code. That's the right word. Just a note, and this is my habit. I still remember this. I did it so many times, but when we are returning back to the OS, okay, of course, what we saved on the stack, we return it back to the OS. I mean, we return the registers as they were, okay? However, any program in the Amiga uses D0 to pass errors and display a message in either shell or on a window in the bar, in the top bar of Workbench, etc. So, if D0 is not cleared, okay, you might get the strange message. Hence, it's good practice that every time you write a program for the Amiga, no matter where it's going to be executed, when you're exiting, you add move quick #0, D0, so that D0 is always clear. However, if you want to debug and have some debugging, you want to pass some debugging messages where you are, etc., you can use D0 to see what the program did, depending on what you pass in D0. So you can make some decisions within the program to pass back errors. This is why sometimes we run a program in CLI and they just return an error when there's nothing to do, nothing. That's because they forgot to clear D0. So here he's talking about the issue that there is when doing programs, when assembling programs that are going to run from Workbench. If you run them from the assembler, you'll enter an infinite loop. So you need to run them from Workbench. You cannot run them from the assembler. That's why we have like a remark, okay, when we add the file, the startup file for Workbench or not. Because while we are testing the code, while we are in the assembler, we do not need that, okay? So actually yesterday I showed this and I'm going to show it today, okay? And in fact, instead of doing assemble A and then J, we do assemble and then WO, okay, to write the object file. Hence, we do example 8b. And we jump to the Amiga. So, first of all, look at this include, okay? The include is remarked, okay? So that because we are in the assembler, we do not need it on. Okay, if we are going in Workbench, then it's a different story. We need to uncomment it. But let's see what it does. Another thing, whatever we want to enable, okay, it's here again, DMA set. And also notice the startup one file is here. Now, notice that we just have start, and this is just our code. There is no more startup file. And look what this code does, okay? So, we have covered all these routines, okay? We have two sprites reading the X and Y value from a table, okay? We have text on the screen, and we have a copper, okay, which we all know how to do. Now, we want this to work in Workbench. For that to work in Workbench, we need to uncomment this. However, because these sources were written to work from floppy, I need to add my path. Okay, so now if we assemble it, okay, it assembled, no issue, but we cannot execute it. We do WO and we write it, and I'm going to write it in my temporary file. Actually, this is one of yesterday, so I'm going to overwrite it. In my temporary directory on DH0, which is called WBWB for Better Workbench, because that's what I use. And as you see, this is our file, okay, which has got the startup file, okay, the test for to run it from an icon, and our routines, our code, our start code, where we had our code. So again, I wish Windows had this. We go onto our Workbench and we find the directory T. So we are in, here is our program that we saved, okay, and we are going to run it. Now, there's a caveat to this, which Fabio didn't think, or he didn't think that computers can be fast in 30 years after. And because I'm running a very fast Amiga, as soon as I click the mouse, it exits because there's not enough time. But eventually I'll get it to work. There you go. So this is running from Workbench now. As you see, we killed the OS. So we were in Workbench. We killed the OS. There's no more OS. Okay? But we saved everything related to the OS. And then we are returning back to the OS. So once I click the mouse button, okay, we return back to the OS. And we have no issue. We ran the program from Workbench through an icon. Before, we were running everything from the assembler. to run it from the assembler, we need to remark this. Actually, I can delete this one. And by the way, the Amiga had already Control C, Control V, Control X, and all that stuff. For those that do not know. At least I'm using it here already. So, as you see, okay, we have covered quite a bit today in relation to the startup file. One thing that I need to mention, for some reason, chapter 8, okay, and I'm going to go back to the book now, just to make you aware of it. It's only in chapter 8, okay? Fabio forgot to put the sections, so I had to put the sections of what's happening, okay, what's coming next. For example, here he's going to talk about how to wait for the vertical blank or for a raster, but in a more advanced way than what we were handling it, okay? So I had to put, there is no sections in chapter 8, so I added those, okay? Also, for those that do not know, if you're on Patreon, you get access to my notes, which I read basically to you when I am explaining the book. So that is another advantage of being on Patreon. I mean, this is where I arrived yesterday in the English version, in the Italian version. So because I'm keeping the English and the Italian versions streams together the same, we will end here. See you next week. Thank you very much, and have a good week. Okay, bye bye for now. Bye. Bye bye.